That's not on. Test, test. Well, that works. Okay. Victoria, can you hear me now? Okay. All right. I got mic level here, and I've got a yes from Victoria. Okay, cool. Let's try that again. So, two parts. First part, how you're evaluated. Second part is going to be about dev tooling. So this is kind of your syllabus. First 4 weeks, we're starting off today with learning software development. That means learning Node, learning about how to test your code and see if it works, how to pair up, work with a partner, also how to debug, which is going to be probably 40% of your life for the next forever. This Friday, we're going to have a mock challenge to kind of get a sense of how you're doing with the stuff that you've learned this week. Next week, you will take on doing your first web app. That means you will be learning about HTTP, you will be learning about the REST style of building routes into a web application, you'll be learning about the Express framework, MongoDB, you'll be learning about how to deploy an application, and we'll have another challenge for you on that Friday. Week 3 is going to be your first front-end week. That is when you're going to learn client-side JavaScript, meaning JavaScript in the browser. You'll also be learning about libraries like jQuery. You'll be getting into HTML, semantic HTML, CSS, the box model layout, and Ajax. Week 4, you'll start off doing databases, SQL, learning about libraries called ORMs. Then you will dive into your midterm project in Wednesday of week 4. So that's when you'll be collaborating and doing teamwork. The thing with the midterm projects, I mean, you saw the ones that were presented today. The goal there is to treat it like it's client work, like you're working in a dev shop and a client has come in and said, this is the project you now have 5 days to build. Week 5. Week 5 is a change because that is an off-site week. That's your computer science week, your reading week. You probably have heard of reading weeks from university. Ours is kind of similar, but you're going to work a lot harder. Some of the topics covered there: object-oriented programming, tree traversal, algorithms, automated unit testing. So it is a remote week, meaning you are not needing to be physically here for that week. So you are at home, you are catching up on sleep, you are doing laundry, you are doing all the things you haven't been able to do for a month, but you're still going to have a fair amount of work. You should be booking 8 hours a day for yourself to accomplish all of the work that is scheduled for that week. It is not a time for catching up on Netflix. We will be communicating a lot more in week 4 about what's going to happen in week 5 and what the expectations are, so you can look forward to that then. Gabe, yes, midterm projects. We did have some of them presented today. You're not doing that in Vic because you didn't have a senior cohort there to present. Good question, though. Weeks 6 to 10, so you'll be back on site for week 6. That is your second front-end week. That's when you are learning React. You're learning about building a real-time chat app. Basically, you're going to build a clone of Slack that week. So you'll be learning libraries like React, Webpack, WebSockets, learning about building single-page applications. Week 7 changes gears dramatically. That's when we're going to be shifting over to the Ruby programming language. So you'll be diving deeper into object-oriented programming. You'll be learning the Rails framework in Ruby. You'll also be learning about adopting code. And what that means is that's getting you ready for the process of joining a company that already has an existing product and building the skills to be able to learn that product quickly. because that's the situation you're going to be in when you go get a job as a dev. You're going to have to learn whatever existing products that company has. So we're going to take you through a process that week of building those skills. Week 8 is starting off with doing more automated testing, but doing it in Ruby this time instead of JavaScript. And then in the middle of week 8, you're going to start 2 things at the same time. One is your final projects. And then the other thing that will start for you at that point is what we call the advanced lectures. So week 8 and week 9, you're working on your final project, working on whatever you decide to do to finish off the cohort. But the lectures that happen for that week are advanced. They go beyond what the curriculum does. And each cohort ends up getting a slightly different set of advanced lectures. We've got about 25 or 30 different topics that we can pick from and you can pick from to give you exposure to things like, but not limited to, web security, infrastructure, deployments, continuous integration, continuous deployment. We've also done things like explaining how load balancers and network attached storage and cloud data centers and stuff like that work. We've gone into other languages. We've done frameworks like React Native for building mobile apps using JavaScript. Lots of different things can come up in that particular week. And then the last week is week 10. That is another remote week because that is when you and your teammates are working on finishing up your final project. You've got some career services stuff that you'll be doing that week. Mostly it's you freaking out and getting ready for demo day. So this is your syllabus. Any questions on this before I dive forward? I have crickets and tumbleweeds. Victoria's quiet. Cool. You will be doing 3 projects that what we call evaluated projects. So you'll do 1 in week 2, 1 in week 3, and 1 in week 6. We have a very project-based curriculum, meaning that you are learning by doing. You're going to build real-world applications, and then these 3 that you will do, you're going to turn them in so that mentors, instructors can give them a full review. And when I say full review, I definitely mean full review. We will be downloading your project onto our machines. We will be running it. We will be testing all of the features that are supposed to be there. You will be given a full list of what those features are and how they are supposed to perform. The rubric that you're going to be graded against is going to be super clear. You're going to see this exact same checklist that we use. But each one of these projects has a set of features that you have to deliver for these 3. And we'll be checking to make sure that they do that. We'll also be doing code review. We'll be looking at things like, did you make good decisions as far as, like for the week 3, the tweeter, it's a clone of Twitter. That's one of your front-end weeks where you're doing a lot with CSS. So we're going to make sure that you made some good decisions as far as UI and UX for that particular project. So these have to be completed and evaluated successfully for you to graduate. And I say evaluated successfully because if we find out, for example, that maybe one of the features doesn't quite work as well as you had hoped it would, then we may push it back to you to give you an opportunity to fix whatever bug is there. So that's not a reflection on you. It's part of the world of software. You may test a whole bunch of things and think that you have it nailed, and we might come along and click once and just ruin your whole day. That's not because we're jerks. I mean, I am, but that's not why we would be doing that. It's just because we know what we're testing for. We know what the software is supposed to do. We're going to do our best to make sure that you've completed that task. There are 2 projects that you're going to do that are not evaluated. This is one that you will do that's a single-day project at the beginning of week 2, so Monday of next week. It's a command line client for fetching information from GitHub. And that one is done very tutorial-based, where we basically walk you through the steps of building it. So there's no point for us to evaluate it because everyone's is going to look the same. And if you follow the tutorial, then it works. The other one is week 7. It's called Jungle. It's a real-world Rails app. It's an e-commerce application, and this is the one that we give to you to teach you about adopting code. So this is a pre-built application that has bugs in it and needs some features added, needs some things changed. There's no point in us evaluating that one because we wrote most of it and we know our code sucks, so we don't need to look at it again. So those two, you have to complete them, but they won't necessarily be evaluated. Other things that will happen throughout the course of the next 10 weeks. You will have 4 tech interviews. Now, tech interviews are a real part of the developer world. When you go out to get a job as a dev, yes, you have the standard personal interview that makes sure that you're a nice person and you're going to fit with the team and that you don't actively drool or any of those other things that an interview might look for. But when you go to get a job as a dev, you're also going to have a technical interview. That is an interview where you're going to have to prove your technical skills in some way or another. That might be reading code, writing code, looking at code, fixing code, talking about code, whiteboarding. There's a lot of different things that particular interview could be. So we've been on both sides of the table for pretty much every kind of tech interview you can imagine. So in these 4 weeks of the program, 2, 3, 8, and 9, you will have scheduled a tech interview that will be with a mentor and instructor, and we will give you opportunities to practice doing the different kinds of challenges that you will see in technical interviews. And the really cool part about that is that we will give you feedback not only, hey Ilya, not only on the technical prowess that you have, but also you as an interviewer. So we can give you professional feedback as well as technical feedback. You will always get written feedback from these, so you'll have something to be able to work on. The other thing about these is that they will always only focus on the material from the week before. So the technical interview that you have in week 3, for example, only focuses on what you covered in week 2. Week 8 focuses on week 7, etc., etc. We do these, yes, they are a point of assessment and evaluation for us, for us going through the course on the education side, but they're also an important part of the career services portion of the course of getting you ready to go out and get a job as a dev. You will have quizzes available in Compass. They will be multiple choice or multiple guess, depending on your viewpoint. They're there for the first 4 weeks of the course. There's a couple really cool things about the quizzes. First is they show up at the end of the day, so after you've gone through the day's material, you can take a quiz and self-assess how well you have learned things over the course of the day. The other cool thing is you can take it as many times as you want. In fact, we encourage you to take it many times with the goal of getting to 100%. And even more importantly, the goal of getting to 100% and understanding why all of the answers are the right answers. So it is a self-assessment tool, but it also helps us to see how quickly you are absorbing new concepts. And then, big scary red slide. So, quick show of hands, who has test anxiety? Okay, anybody who did not raise their hand is lying. Completely. Nobody likes tests. Nobody likes to be assessed or judged or evaluated or any of those other synonyms. We try and avoid it. So at the end of week 2, I said there's going to be a challenge. There's going to be one this Friday. There's going to be one next Friday. And test is truthfully the wrong word for what it is. You're just writing code. It is a project we are going to give you that will be timed. It is open book, meaning you have everything on the internet, Google, every bit of code you have written in the entire course, and the only thing you can't use is another human being. So you can Google anything you want. You can look at all of your previous code for inspiration, and you can submit the questions as many times as you want, and it will tell you where, basically there's a set of automated tests that will run against your code that will let you know whether you've gotten it right or not. And really what we're looking for here is your ability to do things similar to like the katas that you did in the prep course. Being able to sit down, work on a couple of very small focus challenges, write a couple functions that are going to do very targeted things, and then we look at how good your code is. This is not a line in the sand that we use to make dire decisions over. This is literally us just checking in at the end of week 2 to see how you're doing with your fundamentals. That's it. It's no more or less important than any of the other projects that you're going to do. It's not, Scantron where you have to fill in a bubble with a number 2 pencil. And it's not something where if you don't get a perfect score, we're going to come and yell at you. It's not that kind of experience. It's just us putting you in a situation where you're having to work by yourself without mentors and see how well you're doing on your fundamentals. We'll do a mock version of it this Friday so that you have an opportunity to get used to that kind of environment and see how the testing mechanism works. And you'll do one this Friday, and the one next Friday is honestly not that much more difficult because it's covering the same material. It's really focusing on your ability to problem solve and think computationally in JavaScript. Anybody still worried about this slide? Now's the time to ask. Okay. So, things that we've talked about so far for points of evaluation. So completion is you going into Compass and actually saying, yes, I have done this activity. If it requires you to submit code, then you have submitted code for that activity. The completions are incredibly important because if you're not telling us that you've done the work and if you're not showing us the code you're doing, it makes it really hard for us to tell how well you're doing. Code reviews. So pretty much any time a mentor is coming over to help you, we're kind of doing the shoulder surfing thing, looking at your code. You can always call us over to just sit down and review your code, any exercise that you've worked on. We are happy to provide code review because that's one of your best ways of getting better. That's a point of evaluation for us. The technical interviews that I talked about, the project evaluations I talked about. We're going to look at your quiz answers that you'll take each day for the first 4 weeks. We're going to look at the test answers, meaning the code that you submit for that challenge this Friday and next Friday. And then we're also looking at when the mentors come and help you, how well you're doing with each and every struggle that you're having. All of these and more are the ways in which we evaluate you going through the course. This course is not set up for someone to be a valedictorian. If that's something you're chasing, I promise you're focusing on the wrong thing. This course is absolutely set up to track your individual progress. And the good thing is, with us looking at this stuff on an ongoing basis, Davey, Kelly, myself, it's our job to track how you're doing. And you're going to get overwhelmed. It's just the pace of the course. We don't say that to scare you. We just say that because we don't call it a boot camp because it's not like a Mexican all-inclusive. But the good news is if you're feeling about 10 to 15% behind, you're probably right where you need to be. Let us worry about coming to you if there's an alarm, because we are looking at this stuff on a regular basis. We know how you're doing. And no news is actually good news in that regard. Though at any point, if you're feeling like the water is creeping up and you just need somebody to talk to, somebody to sit down and have a moment of sanity, please, please, please feel free to come and talk to us. Keeping it all internalized is not going to help you. But the good news is, because we are looking at all these things, we can let you know how you're doing at any point. That's really what we like to focus on. So that's it for talking about the curriculum and the evaluations. Any questions? Pretty clear? Clear as mud at least? Cool. Victoria, how you guys doing? I say that in the most gender neutral terms, of course. Show. They're good. I'm gonna assume that show is good. Oh, I got a thumbs up. Okay, cool. So now what I want to do is I want to talk about developers and their tools. And the reason I want to talk about developers and their tools is because while Hollywood gets a lot of things wrong when it comes to the mystique and the persona of a developer, if you've watched Mr. Robot or Swordfish or Hackers or any of the other terrible representations, you watch CSI and they're able to crack, NSA firewalls by typing about 12 characters. There's a lot of misconceptions about what it means to sit down and build applications for the internet. But the one thing that is kind of universal through all of it is that someone who is a programmer, a developer, has a certain fluency with their system. A lot of people, they look over the shoulder of someone who's programming and they're just typing away really quickly and weird, curly braces and square brackets are popping up on the screen, and there's just this sense of awe at a developer's ability to be in command of their technical environment. Now, there's a lot that contributes to that, and hundreds and thousands of hours of just sitting at the keyboard and typing will give you a lot of that kind of fluency. But there are things that you can focus on even now, day one of a boot camp, that you can start to think about that will give you that fluency far faster than if you're just going to wait for some magic point of repetition that happens 10,000 hours from now. And in talking about this, I want to talk about things like, let's talk about Sublime for a moment. So, anyone ever had to help their mother or their grandmother, elderly relative of some sort with a computer problem? Yeah, all of us, right? And we've seen things, the quick brown fox jumped over the lazy dog. And so we've got a sentence on the screen, and you need to tell them to do something like copy and paste. So we want to take brown fox and we want to copy and paste it. And you watch them do this, and then you watch them go to the edit menu, and they find copy, and then they click here, and they come down, and they go back to the edit menu, and they click paste, and ta-da, they have done it. And you have visibly aged in the time it took them to do that. And it's because they have done it in the most indirect manner possible. And so I want to start by saying that something you will find as a dev is that mice and trackpads are actually killers of efficiency. So if I were doing that, I would be navigating my cursor to here, Command C, Command V, and I'm done. And that took less time than it took me to use the mouse to highlight it in the first place. Command XCV or Control XCV, if you are on a PC, is your cut, copy, and paste. And as you've probably already learned from Stack Overflow during your prep course, there's a lot of code out there that you want to see if it works, and so you want to be able to highlight it, copy it, paste it, run it, see if it runs. Well, if you're doing that constantly with the mouse and with the menus, you're losing efficiency. For a developer, anything that brings your hands off of the keyboard is something that's slowing you down. And so keyboard shortcuts and understanding the fluency that's possible with your environment become really powerful things. So, for example, if I open up a new tab here in Sublime, which I did with Command N, I didn't go up to File and then do New File and get it that way. Yes, that works, but I'm also playing target practice with my mouse. I have to make sure I click right in the right place, so if I click underneath, maybe, oh, now I'm on the title bar, and, there's all of that. But I can open up a new tab, and I can start, for example, typing some JavaScript. And then I'm going to notice pretty quickly that I'm not getting any syntax highlighting. And this is going to kind of frustrate me because if I want to comment this out, well, now I've got to come up here and manually do this and manually do that. And that's not an easy way to do it. So I need to be able to, for example, set my environment up to know that I'm trying to code. Sublime gives us a really cool way to do this. Command-Shift-P opens up our command menu. And I can say set syntax JavaScript, and it's going to autocomplete for me, and all of a sudden, boom, I have JavaScript. And now when I highlight these lines and I do command/, they're commented, they're uncommented, they're commented, they're uncommented. I can do this all day long, and it's a heck of a lot easier than having to go to the beginning of each line and remember what to type in that particular language. I also get things like syntax highlighting. The different parts of my code are now showing up in different colors, allowing me to know whether or not I have used them correctly, whether or not I have spelled them correctly, whether or not they're matched up in the right place, things like that. If I accidentally delete something, Command-Z gives me undo. Control-Z on PC laptops is going to do the same thing. And now I'm starting to be more in command of my environment. And that is great because if I have another file and let's say maybe I am typing some HTML and I've got stuff in here, and once again it's not being highlighted. Command-Shift-P, set syntax, HTML. And now Command/ if I need to comment it out, it knows which language I'm in. And you'll also notice that when I'm swapping between tabs, I'm not taking my mouse, coming up here, trying to find where my cursor is, having to like zoom in and find the exact right tab. I'm using my keyboard. Command-Shift and my square brackets allows me to zoom through all of my tabs nice and easy. Cool thing, that actually works on any window that has tabs in it. So if I'm in a browser window like this that has a bunch of tabs in it, no problem. I can zip through using Command-Shift and my square brackets. So that's a big help. That is now causing me to save time by leaving my hands on the keyboard when I need to do certain things. If I was here and I had to figure out through my menus how to get this set to HTML, well, if I don't even know what I'm looking for in the first place, I'm going to start off, here, nope, 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 oh, code, nope, that's not it, selection, nope, find, nope, view, oh, syntax, there it is. And then I might scroll down here, find the HTML one, click on that, and then I get, and 6 versions of the library have come out between the time I started that and the time I was actually able to click on it. So I'm saving myself time because I'm not having to take my hands off the keys. Anybody have relatives that sew? Have you ever seen them like thread a needle and do the little swirly thing with their fingers and it magically makes a knot at the end? Well, that's a heck of a lot easier once you learn how to do it than having to like loop it around and lick the end and stick it through. It takes forever. You're saving yourself time by learning these shortcuts, by learning that there's a certain command of your environment that you can have that will allow you to be more productive, which at the end of the day is going to make you a better developer. And it's not just about being able to earn a merit badge that says, I know 72 keyboard shortcuts. That's not the goal of this. The goal of this is finding how to be more productive by being in control of your environment. So we're going to go one more step here. And what I'm going to do is I'm going to, let's see, let's bring in a project here. That's a good one. So what I've just done is I've just brought a whole app project into my Sublime. But I can't really tell right now because my sidebar is not open. I can't see any of my files. So knowing that Command KB is going to open and close my sidebar, super helpful. Otherwise, I'm up here trying to find things and hoping, oh, sidebar, show sidebar. Okay, I can get it that way. But that's a lot of files. That's a lot of folders. Am I going to start at the top and just start, clicking through every single one and opening them all up and, trying to find something that's going to hopefully be useful? No. So I'm going to show you what is probably the most useful, and hopefully after today will be your most frequently used keyboard shortcut. Command T in Sublime, or VS Code, or Atom, or whichever editor you might, that follows this pattern. And it allows me to do things like type a file name and immediately jump to that file. And maybe I'm going to open up a couple different files, and maybe all I have to do is type a couple characters and hit enter, and those files load up. The cool thing about Command T is that it isn't just about files that exist in my project and aren't loaded yet. I've already opened app.js, but if I want to go back to it, I can use these and scroll through, but let's say I've got 25 tabs open. If I just do Command T and type app, hit enter, I'm at that file. And if I want to go back to the connects file, well, there it is. If I want to go back to the cron file, there it is. Command T allows me to swap back and forth and context switch very quickly in any project I'm working on. And right now, most of the stuff you're doing just has a single file, but if you do 6 or 7 projects throughout the day, you may want to go back and look at one you had earlier. Well, Command T and get yourself right back to that file. And when I get to something like Rails in week 7, Rails out of the box has 134 files and folders before I've written any code. So how do I move back and forth between those? Am I going to have to open up 134 tabs in Sublime? By the way, don't do that. But if I know the file that I need, Command T, start typing, boom, there it is. If you take nothing else from this lecture, take Command T, because that is the one that's going to save you so much time in moving back and forth different bits of code that you're working on. The other thing that's really cool is there's a package out there that's free that you can install in Sublime called the Sublime Tutor. And it is literally a set of files that you load them up in Sublime, and it takes you through learning all the different features of the editor. Now, when I'm talking about keyboard shortcuts and I'm talking about efficiency and learning different cool things that the editor can do, don't take this as a challenge that you now have to go and tonight learn every single keyboard shortcut. That's ridiculous. Your brain will turn into jello. Please don't do that. There's enough things that you're going to do over the next week that are going to cause that. This one, it doesn't need to be the way you start. The cool thing about something like Sublime Tutor is you start off and you do one file. You learn 1 or 2 keyboard shortcuts. The next day, you use them for a while. You build up the muscle memory of how to use those. And maybe you learn 1 or 2 more. Maybe you go into something like, Chrome, and let's say that you really liked, what's a good example? Let's go to, you like comedy, for example, and you happen to be on this website and you were chuckling and it was amusing, but you accidentally closed it with Command W, or maybe you clicked on the X and you're like, ah, crap, I wanted to go back and read more of that. Well, Command Shift T gets that right back for me. If you accidentally hit Command Q and close your entire browser, open Chrome back up, Command Shift T, and all your tabs come back. You've just saved yourself, 10 minutes of having to go back through your history and find that link and remember what the keywords were that you Googled. These kinds of keyboard shortcuts are going to save you a tremendous amount of time. So challenge yourself to every day learning 1 or 2 keyboard shortcuts that relate to how you use your computer and how you use your editor. Cut, copy, paste, huge. Learning to navigate back and forth between the tabs will save you a ton of time and a lot of accidental clicking in the wrong place. And then especially in Sublime, where you're constantly going to be modifying text, moving it around, that's where you're going to want to spend some really good quality time picking up some efficiencies. Because every time you have to take your hands off, down to the trackpad, over to a mouse, you're now being a little bit less productive. So put the personal challenge on yourself to take it just a bit further. Oh, I'm sorry if I hit my mic. It could just be bouncing against me. So that's a little bit of discussion about that part of your toolkit. Now I want to talk about a slightly different part of your toolkit. So I'll hop in here to Sublime and just take some notes. You'll see a lot of the lecturers frequently take notes up here so that we can just turn around and send them out to you after the lecture, and you have them. But I want to talk about Git. Now, you've been introduced to Git a little bit, but I want to give you a little bit more depth on it and demonstrate how it gets used. But to understand Git, we have to take a step back and we have to get a little bit of context. Git is of a family of software called VCS, or version control software. You'll sometimes see it referred to as SCM, which stands for Source Code Management. Now these acronyms, we obviously have a lot of acronyms in tech. These two are not ones that you need to have on the tip of your tongue, because the only time you're going to see these is on job postings. And the reason for that is because HR people write job postings, not devs. So there's never going to be a point when James and I are sitting in the kitchen and we're like, hey, did you see that new SCM that just launched yesterday? It's amazing. Never going to have that conversation because we use Git. But you'll see these acronyms come up on your job postings for things like, oh, must be fluent in all modern VCS systems. You're like, okay, yeah, I know how to use Git. I'm fine. But the category of version control software, source code management, is really software that's focused on allowing you to track your changes on something you're working on over time. And to explain why that's valuable, I want you to cast your mind back to, let's say, grade 9. And in grade 9, you probably got assigned to do a project with someone. You know, you had a partner in class that you were going to do the project with. And you probably started off with something like project.doc. And you wrote the title and then you sent it to them to do hopefully more work than you wanted to do. And then hopefully you got it back and didn't have to do a lot. And so first couple times you would email or message back project.doc, and that would be great. But one of you would have a really good idea, or one of you would start doing the footnotes, and all of a sudden you've got project v2.doc. And then you make some other changes, and it becomes project revision, revised version 23.doc. And then it becomes 3 o'clock in the morning, the night before it's due, and it's, this one. This file is the one that gets, sent back and forth, and inevitably at that moment, something critical happens. Both of you have a copy of this file on your desktop, along with all the other copies that have existed, and you make changes in this file, and your partner makes changes in this file, and then you email them back and forth to each other, and they are now completely different. Now, if this were to happen, for example, today we have tools like Google Docs with track changes, or Office 365. Microsoft Word has the track changes feature in it, but you have to go and turn it on for a particular document. But this is the single worst way to manage a project possible, because you are guaranteeing that the changes are going to get out of sync. You are not managing the different versions of your project over time. And really what you have created is just a lot of now dead space on your hard drive that is being taken up by old versions of this project that aren't doing you any good right now. you can't go back and linearly see how that project evolved over time. And you have to hope that this last version, when it gets renamed back to project.doc and gets turned in, is actually going to get you that A. So VCS software is designed to solve this problem. It's designed to just let you have one version of the file, project.doc, and that file goes through many evolutions, and each one gets tracked over time. But you only ever have to deal with one version of the file. And with one file, might seem like a little bit of overkill to have another piece of software monitoring that. But again, let's go back to the example of a Rails project. Like I said, out of the box, Rails has 134 files and folders. So how do you keep track of all of the changes that you make to any or all of those files, plus any that you might add in? Are you going to name them all this way? I hope not. Please don't do that. I will cry. And that's not a pretty sight. So you need software that can actually look at everything connected to a project and allow you to track those changes over time. And that is where Git, as the one that is the industry standard now, comes in. There have been a lot of other VCS softwares throughout the years. There was a really popular one called CVS, which stood for Concurrent Version Systems. We've had SVN, which was short for Subversion. There's one out there called HG, which has the name Mercurial. I'll let you figure that one out. And then there's Git, which is just Git. But they have evolved over time, and there's a really cool story about how Git came to be. Okay, I will move my mic so that hopefully I'm not whacking it. My apologies. So Git was written by a guy named Linus Torvalds. You may have heard of him. He wrote another small piece of software called Linux. And Linus is famous for a couple of things. One of them is being a brilliant programmer. The other is for having a really volcanic temper. So back in 2005, I think it was, 2005, 2006, one of those two, the Linux kernel team was using a VCS system called BitKeeper. And that's the one that they were doing all of their changes on, keeping track of the progress of the Linux kernel that powers the Linux operating system. And one of the developers on the team decided to, let's say, optimize his workflow. He got tired of having to write a whole bunch of different commands to do what were some really common tasks. And so he looked into what was being sent back and forth between the BitKeeper client and the BitKeeper server when he was entering these commands. And he figured out what it was doing, and he wrote himself a script that would automate some of these tasks into a single command that he could run. He was just making his life easier. That's why we have code. Well, the guy that ran BitKeeper got rather upset about this. This is a true story. You can Google it. I'm not making any of this up. The guy got really upset and said that this software developer was trying to reverse engineer the BitKeeper software and put him out of business. So the Linux team got kicked out of BitKeeper. This made Linus pretty angry. He actually didn't have a grudge against the guy himself. He just didn't like being slowed down in the pursuit of building the Linux kernel. So he went looking for alternatives to Git, and he had a couple of rules. Whatever replaced BitKeeper had to be secure. It had to be distributed. He wanted it to be fast. One of his big complaints about BitKeeper, although he really liked a lot of it, one of his big complaints was that it took up to like 25 seconds to merge changes for one developer. And there were 250 different developers working on the Linux kernel team. So you can understand that sometimes it would take a lot of time to merge all the changes in. So it needed to be fast. And interestingly, he had a rule when he was looking for new software that whatever CVS did, don't do that. He really didn't like CVS. To be fair, few people did. So we looked around. They spent a couple of weeks evaluating all of the different competitors that were out there at the time. They didn't find anything. So April 3rd of that year, Linus announces he's building his own. He's really good. April 9th of that year, Git became self-hosting, meaning that the progress of building the software of Git was now being tracked in Git. And April 12th of that year was the first release of the Linux kernel from Git. So in 9 days, it went from, I'm pissed off, I have an idea, I'm going to go fix this myself, to this is now ready for production software. Now, it's been around for over a dozen years. It has gotten better since it was first written, and it was already pretty good when it was first written. Somebody else took it over a couple years after he started the project because he wanted to focus mostly on Linux. And the best part of this story is how it got its name. So I don't know how many of you are up on your British slang. It's a shame that Jenny's not in here because she could tell us even better on this. But Git in British slang is a noun for an objectionable, rude person. And Linus is quoted as saying that he has named all of his famous software after himself. Why shouldn't this one be named after him as well? Plus, Git was 3 letters. It didn't conflict with any other Linux command. It was easy to type. Hence, the name stuck. So, that's the history of how we got this particular piece of software. And this software, 4 years ago, was they did a survey of developers all over the world. A large enough survey, they surveyed like something like 25,000 people. 43% of them were using Git in their workflow. That was 4 years ago. We can't get 43% of the people to come out and vote or pick Coke over Pepsi or chocolate over vanilla or whatever, battle we're putting in front of them. But 43% of the developer population is willing to say, yes, this tool is good enough that I'm going to include it in my daily workflow. So that was 4 years ago. The number has surely gone up by then. And it's because it meets all of these criteria here, which is why it has become so popular. So what I want to do is talk you through what the workflow of Git is so that you have a sense of where its power comes in and how you would incorporate it into your daily workflow. So the idea is that Git as a piece of software is going to control the files in a working directory for a project. Now, each project you're going to work on should get its own directory. If I was starting, let's say I was starting an app for keeping track of my record collection. So I'm going to call it record because, actually we're going to do it startup style, no vowels. So if I'm starting this project, first thing I'm going to do is I'm going to make a directory for it. And I'm going to cd into that directory. And then that's where I start building my project. And it's also where I incorporate Git into my daily workflow so that Git can track all the changes I make in this project. Each working directory that you're going to have is going to get another name associated with it. We're going to call it a repository. Repository, great big word that we typically shorten to repo because it's a lot easier to say. And it's not because it has anything to do with changing the ownership because you didn't pay your car payment. Repo is just short for repository. Oh, Jenny, you're back. I was just talking about the British slang for Git. No? You're Jenny, right? Yes. Sorry, I saw you standing there. I had to pick on you. So, A repo is an individual project. It is not the directory in which you keep all of the projects you have ever worked on. Each directory for each project is its own repository. Now, one of the powerful things about Git is that it is very, has a lot of features, can do a lot of really cool things. One of the downsides, though, is that there are a lot of commands that you have to learn. So in proper BuzzFeed style, I'm going to give you the 11 commands you need to know in Git. Number 6 will blow your mind. Because these 11 commands are going to represent 90%, if not 95%, of everything that you're going to do with Git on a daily basis. And if you ever find yourself in that extra 5 to 10%, that is what senior devs in Google are for. Because if you find yourself in that other 5 to 10%, you have probably gone down a rabbit hole and it's not a pretty picture. So, we're going to start off with how you get Git fired up. And that command is git init. So that's how we initialize a new repository. So let's see this work. Let's see. Oh wow, new year, new cohort. So 2019. Oops. There we go. So now I have a directory for you guys. That's good. So I'm going to make one more for week 1, day 1. And go into it. So now I'm in a directory for the project that we're going to do right now to demonstrate how Git works. And in this directory, when I run git init, I get a command back that says initialized empty Git repository in big long file path ending in .git/. So that last part is the part that's really important to me. The fact that it starts with a dot lets me know that on a Linux-based system like my Mac, that it is going to be a hidden file. When I do ls, I don't see it. The other thing I know from that is because it ends in a slash, it's a directory. So if I do my list all file so that I can see everything that's in this directory, there is .git. Good news, you never need to go in there. There's no need for you to ever have to go in and manually change anything in that directory. That is where Git as a tool is going to keep track of everything for you. And it's not going to get in your way because when you do a normal ls, it's not there. You don't see it. It's a hidden folder. So I have now started this repository, and that means that the changes I make in this directory, Git is going to be aware of. So right now, I have nothing in here, and I want to start a project. So I'm going to make a file. So I'm going to make an index.html file. By the way, I code in Vim because I've been coding in it for like 86 gazillion years. It's where I feel the most productive. It's not about me saying it's the best editor. It is. But it's more about this is where I feel productive. You can go online and find tons of fanboy articles about which editor is the absolute best editor for you to use. I will tell you bluntly, the best editor for you to use is the one that makes you feel productive. If anybody ever tells you that you suck because you use a certain editor, you have my permission to laugh at them, turn around, and walk away. So, let's make a very quick HTML file. And not going to get too fancy with it. And we'll get fancy enough to make it an HTML5 file. Ooh, magic. So I've made a file. Fantastic. That doesn't do very much for me yet. So, second command that you're going to want to know is one of your best friends, and that is git status. So, Git status tells me a couple things. Git status tells me I am on branch master. We'll get to what a branch is in just a sec. It tells me that I have no commits yet, meaning I haven't marked any points in time where I feel like I've made progress. And there is a file in the directory that is not currently being tracked. It shows up in red, index.html. Git is even helpfully telling me I can use git add and the name of the file to include it in what will be committed. So a commit is a milestone. It is a point in time in which I can say, yes, I've made enough progress that I want to keep track of this moment. You know, for example, if you were starting your great novel that was going to be, you know, your contribution to the literary world, or Twilight, then you would probably not want to mark the point where you had an empty page, but maybe when you had written the first chapter. That would be a point in time where you'd want to say, yes, I want to remember this point and then work from here. That's what a commit is. And a commit exists on a timeline because it is that point in time. And within the world of Git, we call timelines branches. And on a project, you can have multiple branches. Why would you want to do that? Well, for example, you might have an English version and a French version of your project. You might be trying out 2 or 3 different charting libraries. And so you might make a different branch for each one so that you can try each one out and see which one works best. You might, most commonly, you're going to have branches to represent the work you do on each and every feature that you're going to build. We'll see how this works. First off, let's keep track of git status as our second command. And let's follow Git's advice. And I'm going to git add index.html. I get nothing back, which is good, no errors. And I'm going to type git status again. You should notice a significant change unless you're colorblind, in which case I will tell you it turned green. This is actually important because there's an entire theory that exists in the world of software development called red to green debugging. If you are standing in front of a status board, if you've ever watched The Simpsons and seen Homer at work, you know that bright red flashing lights are bad things. Green lights are good things, right? Red means stop, green means go. It's not about Christmas. So I've taken that index.html and I have moved it from a red state to a green state, meaning it is now good to use in my project. I've added it to Git. So that becomes my third command here. So now I have a change that I have made to be committed, meaning Git says, hey, I'm ready to mark this moment in time. So I'm going to git commit. And here's one of the things with Git is that it wants you to document the work that you do. So when I make this milestone, when I create this commit, I'm going to add a message to it. Not terribly verbose, but descriptive. It says what happened with this commit. And again, you can go online and find a nearly religious war about what tense you should use for your verbs and how these messages should be written. The key thing is be clear. With this commit, I created an index.html file. I fixed the bug in the login method. I changed the library being used for encrypting passwords. These milestones, you should be able to describe what that milestone is. This is your log of the work you have done on your project. It's also the log that another developer is going to look at when they go to work on the project and want to find out when certain work was done. Which is why FDSA JKL semicolon crap 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 is not your best commit message. It's easy to type, and it's probably a good point of frustration when your code hasn't been working the way you wanted it to, but it's not the right kind of message that you want to use to document your progress. So I've made that commit. Let's keep track of that command. And it's told me a few things here. It's told me that I'm on the master branch. The root commit shows up for the very first time I commit to a project. And then there's that jumble of numbers and letters. That's actually a unique identifier in my project for this commit. That unique identifier lets me come back to this point in time anytime I want to. If I want to rewind, go back in time on my project, I could work on this for 10 years. But with a command I'll show you in a minute, I can go back to that identifier and rewind my project back to this point where all I have done is created an index.html file. And I can move forward or backward in time to any commit that I make. So there's my message, created index.html file. And it tells me that one file was changed and that there were 9 insertions. So this tells us something really cool about how Git keeps track of changes. Git tracks the changes between one commit and another, and it keeps track of them on a line-by-line basis. So it says 9 insertions because my index.html file has 9 lines. So if I were to add another line, then that would be one more insertion. And when I'm moving forward and backward in time, that really efficient way of storing the differences allows Git to replay or unplay any set of changes quite quickly and quite efficiently. So that's how Git stores its changes. And then it tells me that it has created that file in my repository. And still, all I see in my directory is just index.html. So, at a basic level, I've got a timeline. I have a project that I'm working on, and I'm able to track changes on that over time. Now, Git does not care how many times I open, change, or save this file. What Git cares about is how many times I commit the changes I make. So if I'm working on this, I might make 100 changes, I might spend 2 or 3 hours working on it until I get it to a point where I'm happy with the status of this work. And then I might make a commit at that point. I might go in, change one line of code, fix the bug that was causing the problem, and I might commit right after that. My commits are going to represent my milestones in progress. It's not about some arbitrary number of saves, or I've written 273 characters, I have to make a commit. It's about you making progress and marking those points in time where progress has been made. So you're in control of how often Git keeps track of your changes. That also means that if you go for an entire day, touch 412 files, fix a whole bunch of bugs, and then you make one commit, you've lost all of those individual steps of progress. So committing at the points where you make progress is a good idea. There is no silver bullet formula for how many times you should commit or how many times you should branch or anything else. What there is the tools for you to be able to track your progress. So let's see how we can do that using this tool in a couple even better ways. What terminal am I using? I am using ZSH. So I'm going to go into this file and I'm going to add some more content. And I'm going to save that file. Git status is going to tell me now something a little bit different. Git status is going to tell me that that file has been modified because Git knows what it looked like at the last commit, and now it's different. So all it's telling me is, hey, that file's been modified. I might not be done with it yet. Okay, now I'm done with it. Now I've added enough content to feel like I've made some progress. So once again, I'm going to, well, when I do Git status, it tells me still same thing, that it's modified. And what's interesting is that it's telling me I can use git add to add it to what will be committed, command we already know, or I can use this little shortcut, git commit -a. So I want to tell you what this does. You'll see people a lot of times they'll use A and M together, and they'll put a message on here, and they will hit enter. What they just did when they did that was they committed all of the changes that they made in this directory since the last commit was made. That may not always be what you want to do. Because let's say that you've gone and you went and had a couple different things that you were trying to address. You might have touched this file over here, and this file over here, and this file over here, but you found the bug in this one file, you changed it, you fixed it, you saved it. That's the one that you would want to commit. If you do git commit -am, you might potentially be saving all of those other changes you made, and they may not be related to the work you did to fix that bug. Git commit -a is a nice shortcut that allows you to just save a whole bunch of stuff at once, but I'm going to encourage you to be a little bit more selective in what you're saving with each commit. Yeah, Shmoo. Aha. Okay, so the question there is if you do git commit -a and you have files in the directory that have not previously been added, will they get added? No, they will not. Git commit -a is only going to save changes to files that were in the repository and you have modified. Good question. What's the difference between -a and -m? Yeah, -m is just the message. -a is all changes since last commit, but you can do them both at the same time. So here I am going along, and here's my log, git log. Great command to know. It shows me all the changes that I have made over time. And remember I showed you that little jumble of letters and numbers? It's actually the beginning of a much larger string. But the first 7 characters are all that's necessary to be able to demonstrate it. The new one is 929D27. Et cetera, et cetera, et cetera. So the big long hash there is what Git keeps internally. You only ever need to worry about the first 7 characters. That's what you need to worry about. So git log, new command. Let's keep track of that one. So now I'm at a point where I want to start experimenting with some different things. So I am most likely, at this point, am going to create a branch. I'm going to create another timeline to track my work. The easy way to do that is with the git branch command, and I'm going to give it a name. Let's give it the name more content. Now, I got nothing back, silent success. And git branch, if I just type it by itself, it's going to show me a list of all the branches that I have. So this is one of the occasionally confusing things about Git, in that one command can do multiple things depending on what data I give it. So git branch by itself shows me all the branches I have, but git branch space and the name of a branch creates a new one. Now, I'm still on master. I want to change over to my other timeline. Within Git, anytime you want to change your timeline, the command is checkout. So git checkout, more content. It tells me that I switched to the branch more content. You'll notice that my prompt updated as well. Your prompt in Vagrant will do the same thing. If you're on a Linux box and your prompt isn't set to recognize your git branch, you just have to Google, bash prompt git, and it will show you how to do that. It's really simple. So now what I'm going to do is, now that I'm on this new branch, I'm going to add some more content. That's enough. So I've added more content. I have done what I said I was going to do on this branch. I'm going to save it. Well, let's git add index.html, git commit-m, added more content. So, I now have, on this timeline, this version of this file with all that content in it. Once again, our checkout command is how we change timelines. So I'm going to swap back to master. And I'm going to show you the most common freakout that new developers have. Oh my gosh, Git ate my work. This tool is horrible. Why did you make me use this thing? I just coded for days and it's all gone. Why did you make me use this? Well, Git has not eaten your work. You've just changed over to a timeline where that progress hasn't been recorded. It still exists in the other branch, in the other timeline. And what that allows me to do is it allows me to use my master branch as the clean working version of my product at any given moment. The code that I keep in my master branch is intended to be the current version of my product that works, that if somebody downloads it, it works the way you would expect it to at that point. My features, my bugs, my content changes, my translations, my experiments, all of those things, I keep that work in my other branches. And then once I'm satisfied with that work, I can bring it back into my master branch. But until then, I want to keep track of it over there. I don't want my development work to get in the way of what is the working version of my product. You know, if you've ever, for example, had to make sandwiches for a soccer team or something like that, you make the one that is perfect and you try and get all the other ones to match that. That's your master branch. So on my master branch, I don't have that work. But if I go back over to more content, there it is. Yeah. Mm-hmm. Oh, that's a good question. Okay, so let's say, so the question here is, let's say that I was on my master branch and I made some changes. So I added content into this file, I saved the file, but I didn't commit it, is what you're saying? Didn't commit it. Let's play this out so you see what happens. So I'm on my master branch. Here I am. I've now made some changes. My git status tells me that file has been modified. If I go to check out more content, it won't let me because those changes would be lost. So it tells me that my local changes to the following files would be overwritten by my checkout. I need to either commit my changes or stash them before I switch branches, and that it aborts that checkout. So I'm still in my master branch. So it's telling me that I would actually need to commit that before it lets me change the state of my working directory. So let's go ahead and do that. Wow, can't type today, sorry. So now I can check out more content. That paragraph that I just created, not here, but the list that I had built earlier is here. That represents the more content I added. So now that I know how to move between timelines, and especially how to take work that I'm going to do on a specific task and keep it in a branch, I need to figure out how to get my code back in. So the same way that a branch branches off, if I want to take this work from this parallel timeline, I'm going to merge it back in. So git merge, I go to master, and I have new work over here, and I want to merge it in. So I'm going to merge in the branch that I want to bring in. And it tells me that something bad has happened. It's why I wanted to actually act out the scenario you presented, because we have a problem here. And this is one of the problems that was built into Git deliberately. And this one was built in because Linus was so upset about how some of the other version control systems handled this scenario. So the scenario is that we have a file, and whether it was me that did it with 2 different branches, whether it was multiple developers in many places doing it, the same line of that file has been modified on 2 different timelines. Now, because Git keeps track of its changes on a line-by-line basis, if I change line 1 and over here I change line 10, Git is just going to merge those together with no complaints whatsoever. Even if in my line 1 I add 100 lines, it now knows that line 10 is line 110, and it merges those changes with no problems. So Git is very smart and very fast in that regard. What's gone on here is that the exact same line of text now has 2 versions of it in 2 different timelines, and we have what's called a conflict. And other systems would do things like, whoever committed first, you lost, because the new commit would just stomp over yours. That kind of sucks. One version control system that shall remain nameless would have different permissions for how, what level of admin authority you had in that repository, and the higher the permissions determined who would win in a conflict. Well, Git takes kind of the Switzerland method. It's neutral. It's not going to get in between mom and dad when they're fighting. It's not about to pick sides. It is going to want you as the developer to solve this problem. So let's look at what it's done to our file. Very specifically, it has modified the file in a very particular way. I have a whole bunch of left angle brackets, and it says head. Well, head represents the end of my timeline, the most current point in my timeline. In my master branch, at the end of my timeline, is that paragraph tag that I added there. Then there's the equal signs, and everything between that and the right angle brackets is what was in the other timeline. So that's the list that I added in the more content branch. So what Git wants me to do here is to make a decision as a human being, to use all the squishy gray matter up here, and to decide what the right version of this file should be. And then once I make that decision, I have to add this file back into my repository and commit those changes in order to be able to move on and keep tracking things. So I'm actually going to decide to keep it all, because why not? And I'm going to get add index.html. Resolved conflict. And now my Git status is happy. But before, it didn't want to let that merge happen because we had this conflict here. Conflicts will happen. There's a bumper sticker that says something very similar. Conflicts will happen, but on a team, you can avoid most conflicts with good communication. And just you as a developer working solo on a project, you can avoid most conflicts by just kind of mentally keeping track of where in a file you have edited for any given task. Worst case scenario, you have to manually edit the file. It will take you about 30 seconds. That's the worst case scenario. You haven't broken it. Git is just saying you've got a conflict between 2 timelines, and you as the human have to resolve it. So now we've been able to branch, and we've merged the content. Oh yeah, question. Mm-hmm. Great question. So the question is, when I merged back into the master branch, what happened to the old branch? Did it disappear, or is it still there? So if I do git branch, that branch is still there, and it will always be there unless I go and manually delete it. Yeah. The reason is we may want to merge a certain milestone in, but we may not be entirely done with that feature. But maybe there's a bug fix that we made that our team members need or something like that. So it allows us to kind of bounce back and forth, and branches never go away unless you manually delete them. So, so here I am. I've made a bunch of branches. I've added a whole bunch of features. I've done login. I've done forgot your password. I built a database, all the great things that go into a web app. But one of the things we haven't talked about yet is the part of Git that is distributed. And that was one of the rules that Linus had for it. So what does distributed mean? It means that we are able to work on the same project anywhere in the world and be able to share code back and forth. So I'm going to pick on Dan because he's sitting right there. So Dan and I are now starting an internet startup. We're both billionaires. We're buying our Bentleys tomorrow. But Dan, he gets to stay here in Vancouver with beautiful weather, and I have to hop on a plane and fly somewhere else. I get to go to, I don't know, Kansas. But we want to keep progress going on our startup because new startup, you know, momentum, the faster we get out there, the more money we get. Maybe that second Bentley would be really nice. So we are going to need to be able to share code back and forth. So if Git is managing the directory locally on my machine, I need to be able to share my commits, the changes I've made, with him on his machine and vice versa. He needs to be able to share his code back with me. So this is where we get into the concept of what's called a remote repository. So we're going to use GitHub to represent Dan. So GitHub, I'm going to take all the mystery away. All GitHub is a website that lets you create a copy of your repository on their computer. At the end of the day, that's it. It's a web interface to allow you to manage a Git repository on somebody else's computer. In this case, it's Microsoft's. So I'm going to create a new repository, and we're going to call it Jan7 intro Git. And it's going to be public, because I can't do free private ones until tomorrow. And it's going to give me some commands here that I can do that allow me to get this set up on my computer, because this is only on GitHub's computer right now. So it says I can create a new repository on the command line, and there's our good friend git init that we learned about earlier. Git commit, git push. These are commands that I would use to manage this. But I'm in the second scenario here. I have the repository. I've made the index.html file. I want to be able to push that to Dan so that he can work on it. So here's the commands I'm going to use. This one is nice and big and long and doesn't make a lot of sense when you first look at it, but let's talk through it. Git remote. So I'm now managing the remote part of Git. I'm going to add a remote, meaning another computer somewhere on the internet that has a copy of this same repository on it. It's going to get the name origin. Truthfully, it could be anything. Origin is just a word that has come up as a convention for meaning the main other repository that you're sharing with. It could be rutabaga, it could be soccer ball, fluffy bunny, whatever you wanted it to be, as long as you knew what that was. It could be, it's any label you want, it's cosmetic. And then this big long address is the address of that folder on that computer on the internet, so that wherever I am in the world, I know how to get to that copy of my repository. If this was Dan's computer, I might have an IP address or something like that, or a domain name that I might be connecting to. As long as that is an address, that means I can always get back to that repository on that remote computer. So I'm going to grab this command. I'm going to go to the right window, and I'm going to paste it in. Silent success. I have now added this remote to my repository. And the second command it gives me here is git push origin master. So what that means is I want to take the changes I have made and I want to push them to the remote named origin and its master branch. I could push to another branch if I wanted to, but I'm just going to push to the master branch. This -u here sets up this remote and this branch as your defaults, so you can just type git push in the future. But I'm going to copy this one. And what's going to happen is it's going to take all the changes I've made in my repository. It's going to push them up to that remote place on the internet. And ta-da, there is my index.html file. So now there are 2 copies of this repository on the internet, and I am able to share code back and forth between them. So, git remote, git push. Well, guess what the opposite of push is? Very good. You get a cookie. So let's say that Dan is coding away furiously. He's got the index.html file, and he makes a change. He has made a change. He's going to save his change, and he's going to make a commit. And he's going to commit that on his local machine. Now, if he had me set up as a remote, he could push to me. But because I have him set up as a remote, I can pull. I pull his changes down to my machine. And there's Dan's list item. Yeah, Shmoo. Yes. That's Dan. So I'm using GitHub to emulate Dan's computer. So when I set up my remote, it's just the address to where that other repository is. It could be GitHub, it could be on his computer, it could be on a server on Amazon Web Services. The remote is ultimately just wherever that other copy of the repository is. Yeah, so that me changing text on GitHub was me pretending that I was Dan, because he was working and I didn't want to bug him. Yeah. Cool. Yeah, Gabe, I am trying to repeat the questions. I promise I'll get better. So that question was about, wasn't the remote just on GitHub, but that was why I explained that the remote was Dan. So one thing with pushes and pulls is that if there is a conflict between the work I have on my machine and the work that, for example, Dan would have on his machine, it will not let me push. It will not let me create a conflict in his repository. I have to pull his changes in and resolve any conflicts myself in order to be able to push those changes back to him. And same thing, he can't push changes to me that would create a conflict on my machine. Basically, he can't put my project in a state that doesn't work because of a conflict. It might not work because of bad code. That's a whole other thing that I talked to him on Slack about. But he can't push and create a conflict on my machine. Git won't let you do that. So in any case like that, and you'll actually get a very distinct error from Git that will say, there are changes that you don't have locally, perhaps you should pull first. Yeah. Mm-hmm. So the question there is, in the case where you've got multiple developers working on the same file, is it best practice to communicate and say, hey, I'm in this file right now, give me some time to finish it off before you go in there and make changes? Yes, 1000%. Communication solves pretty much all conflict problems that you will have. There's always the very common case where somebody's going through a file and they're like, oh, that's misspelled, I'll fix that typo real quick. They don't realize they just, caused a conflict on somebody else's machine because that person also made that change. And so Git's like, hey, both of you edited the same, same line of the same file. I'm not getting in the middle of that one. So yeah, good communication solves that problem pretty much all the time. And the other thing is that's a strong case for why doing it in different branches is the best practice. Because if each one of you is in your own branch on your own local repository, you're generally only going to be pulling code in when it's clean working code that you're bringing into master. That's when you're going to do the push and pull to make sure that any changes that your partners on your team may have made to say, hey, this is working code, you're only ever pulling in working code. And still good communication keeps you from stomping on each other's work. So yeah, that really is the secret to the whole thing. Git can't solve all the problems, but it can solve most of them. Good communication pretty much fixes the rest of them. So, 11 commands. Number 6 wasn't quite as exciting as I hoped it was going to be, but it all depended on which order you got to them. But these commands represent your workflow. You're going to start a new project. You're going to initialize your repository. You're going to get your initial environment set up, make branches, build features, fix bugs as each piece of code works, bring it back into your master. And that workflow of constantly making branches, doing your work there, communicating with your partners if you have a development team going, that is the workflow that you as a dev need to know before you go and get a job. Yeah. Mm-hmm. Okay, so the question is, right. Okay, I'm going to explain it back not only for Victoria's benefit, but to make sure I understand your question. Words are hard, I get it. So in the case where you are pulling in changes from a remote repository, and you could have many remotes, you could have 25 people on your team and be pulling from each one of them. So in the case where you're pulling in changes to your machine, if there are changes to one of the files that you've worked on, is that going to cause a conflict? The only time it's going to cause a conflict if both of you have edited the same line of the same file. That's the only time collisions happen. The scenario, like I said, if I edit line 1 and somebody else edits line 100, no problem. Git is just going to knit those together because it tracks those changes on a line-by-line basis. Even if I added, deleted, grew or shrunk the file, Git knows where those lines are and will knit them together with no problems. It's only ever if there's 2 changes to the same line in different timelines. Communication solves all the other problems. Git is actually quite smart about being able to merge changes. It's kind of eerie, actually, how good it is. And it does it so quickly that you don't even notice. So it's actually a really powerful tool in that regard. Cool. So that gets us through an intro to Git. Like I said, there are many other commands that are out there. These are the 11 that you want to start focusing on. And I'm going to go ahead and I'm going to throw down a metaphorical gauntlet. And I'm going to say that today's the day that you want to start building the habit of working Git into your workflow. In about 3.5 weeks, when we get to the point that we're kicking off the midterm projects, whoever gives the lecture that day is going to stand up here and is going to say, you remember on day 1 when we talked about Git and we said, hey, you need to learn it? And half the room at that point, I can guarantee you, is going to go, because you probably won't be fully embracing it because you've got so many other things that you're trying to learn. But I'm going to tell you that the sooner you build this into your workflow, the better off you're going to be. This isn't something that you wait until day 1 of your new job and then go, okay, I'm going to figure out this Git thing once and for all. The sooner you start practicing it, the better off you're going to be, and I promise it will make a huge difference in your productivity and in the overall integrity of your projects. There won't be accidental deletions, and worst case scenario, Godzilla steps on your laptop and you've pushed everything up to GitHub. All you have to do is check out all your repositories again, and you don't lose any time whatsoever. There's really good reasons for using Git. It is an infinite undo. It is a perfect backup if you're pushing it up to GitHub. It will save you a lot of time and grief. Any questions? Cool. So what I will do is I'm going to send out these notes. I will send out a link to the repository, and I will also send out all the terminal output from what we did. So you'll have those as reference. I'll send you a copy of the slide deck from the beginning as well. Anytime you have a lecture, your lecturer will send out notes afterwards. So you will get an email from Compass that has the lecture notes in it. You're also always able to go back into Compass, click on the lecture activity, and get access to the video of the lecture, the notes that were sent out for that lecture. You can even see other lectures that were given by other instructors, both here and in Toronto, on similar topics. So if you didn't like my bad jokes and you like somebody else's bad jokes, you can go listen to theirs. So that resource is something that's always available to you. But I will let you guys dive back into curriculum now. Thank you.